All right, good morning and welcome to week six's video. It might be good afternoon to you guys because my guess is you're not up as early as I am. But welcome to week six's video. In algebra and geometry class this week, we're going to actually spend a lot of time reviewing the algebra portion, the heart of algebra portion. And I'm actually creating a video for a little bit of the geometry portion. So it's going to be crucial that you guys watch that, and I'll reiterate that in class again. All right, so welcome. Let's see if the iPad pencil will connect. Welcome. And today's topic is going to be, I can solve a system of equations in an angle relationship. So we're still talking about relationships. So we need to be very clear that this unit is all about the relationships in geometry, specifically the angle relationships. So we're going to talk about an angle bisector or a perpendicular bisector. We are also going to talk about an angle bisector. All right. So what is a perpendicular bisector? Well, before we can define a perpendicular bisector, we should probably redefine the word perpendicular. And take a pause. What is perpendicular? You're right. Perpendicular means that lines or line segments or rays meet at 90-degree angles. Okay. And again, now pause, take a second. What is a bisector? You are correct. Bisect means to cut in half. So for our intents and purpose, we're going to go ahead and we're going to look at what's called a perpendicular bisector. So before we can start talking about a perpendicular bisector, we need to talk about a line segment. Let's go with this line segment. And we're going to call this line segment AB. Okay? And what we're going to do is I'm going to choose another color. We are going to cut this line segment in half, and that's I'm sitting at an angle, so that's a really, really bad line, so let's redo it. So we're cutting AB in half with this line segment, and I'm going to call this XY, and XY cuts AB in half. Therefore, what do we know? We know AX is congruent to AB, or XB. Okay, they're congruent because they got cut. XY cuts AB in half. Okay, so property number one, cuts the line segment in half. Property number two, makes a right angle with a line segment. Therefore, we will say the measure of angle AXY is equal to 90 degrees. Now, every point on the perpendicular bisector is equidistant from the endpoints of the line of the segment. Now, this one seems a little bit kind of maybe foggy, maybe a little bit more challenging. So let's say that we have this point Q. And what this one means, this property means, is that from Q to B and from Q to A, these values are the same. And that's what those two lines mean. Those two lines mean that they're congruent to each other. What it also means is if I were to put a point up here, call it P for point, very, very challenging. This distance and this distance, ooh, that one didn't want to straighten out. Undo. All right, let's see if it'll erase it. That's better. Wow, straight lines are not my forte today. Okay, so this line and this line are congruent to each other. Now, is AP congruent to AQ? No, they're not. Notice the lines that I drew. I did draw them differently so that way we could tell that they were not congruent. Okay? So that's what this means, that every point on the perpendicular is equidistant, equidistant meaning same from the end points of the line segments. The other thing that actually happens as well is that these angles end up being congruent to each other because we cut it in half. So hopefully that makes some sense. Now let's actually do a couple of examples. All right, first of all, read it. Bingo. RC is the perpendicular bisector of PQ. So that means I know that this distance PR and RQ have to be the same length. I know PC is 3x minus 2 and QC is equal to 10 and it says find x. Now, what do we know about point C? Point C to Q and point C to P, these are congruent to each other. So if they're congruent, we can write an equation. You're right. We're going to write 3x minus 2 is equal to 10. Now we're just going to algebraize it by adding 2 to both sides. 3x is equal to 12. Divide by 3. X is equal to 4. And that's what we were being asked to. Now, how can we test it? We can go over here and we go 3 times 4 minus 2. 3 times 4 is 12 minus 2. 10 is equal to 10. So we tested it out. Let's do one of these. Which one do you want to do? 3, 4, or 5? Awesome. I like number 4 as well. So AD is perpendicular to CB. There's my symbol. AD and CD. AD and CB are perpendicular. I know AD is a bisector because CD and DB are equal to each other. So therefore, point A is equidistant from the endpoints. So now we're just going to set up our equation. 3x minus 6 equals x plus 18. I'm going to subtract x from both sides. 2x minus 6 equals 18. Add 6. 2x is equal to 24. X is equal to, ding, 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 12. You got it. All right. I want you to pause. Pick one of the other 2 problems to do. And I'm going to just reveal the answers to them for you. This one, x is equal to 6. This one, 3x is equal to 3. So hopefully you pause, take a break, try those out. All right. Now, this one looks a little more complicated because it's got x's and y's. So xy bisects AB. Oh, I don't have letters, so let's label. AB is this one. This is y. This is x. So xy bisects AB. It is bisecting at perpendicular, so we do know that this distance is congruent to this distance. This distance is congruent to this distance. So AX is congruent to XB. AY is congruent to YB. So now I'm going to set up equations because now I've got 2 sets of equations with 2 unknowns. And ding, 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 if you paid attention in class, you know that if we have 2 unknowns, we need 2 equations to solve them. So I'm going to write my 2 sets of equations. For AX and XB, that's going to be 2x plus 2y is equal to 12. Right? Yes, because x is equidistant from A and B. And then we are going to compare AY and YB, and that's going to give me y is equal to 7x plus 6. Now, again, hopefully you guys have paid attention in geometry class because this is a system of equations. What method might be the best one to solve this one? You're right if you said substitution. So we're going to go ahead and substitute. Remember, that means I'm going to take the 7x plus 6 and I'm going to put it in for y. So I'm going to keep my 2x. plus 2, but instead of times y, I'm going to replace that with 7x plus 6 equals 12. So now I'm going to distribute to both pieces. Don't forget that. So 2x plus 14x plus 12 is equal to 12. 2x plus 14x is 16x plus 12 is equal to 12. Subtract 12. 16x is equal to 0. Oh, well, the 0 is a number. We're allowed to have 0. So we're going to divide by 16. X is equal to 0. Now we found x. Now we have to find, you've got it, we got to find y. So I'm going to take y, and I'm going to do 7 times 0. Add it to 6. 7 times 0 cancels. It's 0 plus 6. Y is equal to 6. So what's my point of intersection? Because in geometry, we talk about that. We're going to talk about x being 0, y being 6. Awesome. Hopefully nothing major with that. All right, so what's an angle bisector? Well, let me actually draw you a picture first. So we have an angle. Let's call this angle P. We'll go A, P, B. And what I'm going to do is I'm going to bisect this angle. So I'm going to have a ray that comes out from P and cuts this angle in half. Let's call it PX. So angle APX is congruent to angle XPB. They're congruent to each other. Okay? Now, if a point is on the bisector of an angle, so that's going to be on my pink line, then the point is equidistant from the sides of the angle. Well, the cool thing is if I choose a point here, if I figure out how far it is to the sides of the angle, we always measure distance. Whoops. We always measure distance as perpendicular distance. So that's that note right there, is that we have to call it perpendicular distance. And I obviously did not draw very well today, so I apologize. But what we're saying is that this line and this line are congruent to each other because they are equidistant from the sides. And that's if we cut an angle in half. Now I could stretch that point. This point Q, it could go out towards X, it could go in towards P, and regardless, that perpendicular distance is equidistant. So you've may have heard the saying, the straightest, the quickest line between 2 points is a straight line, and that's going to be a perpendicular distance. That's going to be our straightest distance, and it's also going to be our shortest distance. All right, so what's that mean? Let's look at these two examples. So I know that MO is the angle bisector, so I want to find X. So that means LMO, this one, is congruent to NMO. Angle LMO is congruent to angle NMO. So that means this and this have to be equal to each other because they're equidistant. So that means 4x minus 5 equals 23. We're going to add 5 to both sides. 4x is equal to 28. Divide by 4. X is equal to 7. Perfect. All right, take a quick second, write the equation for the next one. Yep, you got it. If you said x plus 7 equals 2 times 3x minus 4, distribute, x plus 7 equals 6x minus 8. Yes, mental math. Subtract, let's subtract x from both sides. 7 is equal to 5x minus 8. Let's add 8. 5x equals 15. Divide by 5. X is equal to 3. Nice work, guys. And that is our geometry portion of week 6. And again, I think this is less complicated than the algebra portion. So algebra portion is what I want to spend time in. Again, when we hit week 7, are you going to be able to ask questions? Yes. There will be a series of problems in your workbook that you need to do based on this. And then there will be delta math based on our algebra lesson in geometry class. Hope you guys are staying safe and staying well. I will talk with you later.